All right, so I want to do number 13 and 18.1, which says I want to integrate the vector field x comma y over the path from 2, 0 to 6, 0. Right? Okay, so wait, hang on. Maybe we should think Priya's way.
And we won't do anything with the wires?
Yeah, so my path, right, the y's don't change, right? So I could really think about this as integrating x dx.
Last time you made it 1 when you said that the y is doing it, why would you right here? Or actually, no, I see it, because you're starting with
Yeah, so I have a vector field, right? So this thing breaks into p plus q, right? That's pi plus qj. This, I said I wasn't going to work in the books notation, now I am, right? So they have the integral over x dx plus the integral of y dy, right? Both over this path. But on this path, there's no dy component, right? Because the y's don't change. So I can just pitch this piece. That's 0. So I'm just left with the integral of x dx. And where do the x's vary from?
2 to 6.
They go from 2 to 6. And because this is an easy path, right, I can get away with just declaring x prime as 1. You see that? Okay, so do this. You get x squared over 2, I think, evaluated from 2 to 6. Cool, cool. All right, so we got whatever you get. Bulls. No.
Yeah, it's a 16, but yeah.
Sure. Or a number. Cool. So, yeah, when there's x's and y's in here, right, you really should have to evaluate them at the path you're executing. If you want to do this thing in my notation, really what I'm doing is I'm taking this guy, my path from 0 to 6, 0, and I'm thinking about that thing as, okay, so r of t is x comma, r of x maybe, is x comma 0, right? And the x's range from between 2 and 6. You guys with me on that?
Yep.
And then r prime, right, is just a vector 1 comma 0. And f of r of t is x comma 0. So this guy
the one just disappears, right?
is just x comma 0 dotted with 1 comma 0. So the 1 comma 0 is what turns this into a scalar, right? So that I can actually do this integral. That's cool. You'll get the same answer either way. What's up, Rick?
Hypothetically, so this process is always work if you just did basically the x prime dx, y prime dx.
Mhm. Yep. Yeah, and you can totally do line integrals that way. It's just kind of an old school notation. If you want to do line integrals that way, I'm not going to stop. Yeah.
That's how I was initially.
Yeah, and it's just it's an old school thought versus slightly new school thought. I suspect, don't get me wrong, the new schoolness of that thought is due to engineering. And the old school is kind of a physics notation, but I could be wrong.